Hey guys, welcome to the second tutorial of the TensorFlow beginner course. Today we learn the tensor basics. A tensor is the central object in the TensorFlow library, so all operations are based on tensors. And a tensor is kind of like a Numpy ND array, so you can represent 1D, 2D or 3D arrays or arrays of even higher dimensions. But so let's write this down. So let's say we represent ND arrays, but a tensor is also designed so that it has GPU support. So we have GPU support. And a tensor is also designed so that we can build a so-called computational graph and then later track compute the backpropagation. So for here, for example, we multiply two tensors with each other, and then we build the so-called computational graph, and then the next operation is a subtraction. So this is also an operation in our computational graph. And then later we can use this to calculate the gradients. So it's used to build a computational graph and to compute the backpropagation later. And I already have a tutorial about this in my PyTorch beginner course, but the same concepts apply here too. So if you're interested in this, then check out the video. I will put the link in the description. And then what's also important about tensors is that they are immutable. This means that we can never update the contents of a tensor. We can only create a new one. So now let's start creating some tensors. So first of all, of course, we want to import our TensorFlow library as TF. And then in order to create a tensor, we use the tf.constant function. So we say x equals tf.constant, and then we can give it a value, for example, only a single scalar value. And then let's print our tensor. And let's run this file and see how it looks like. And then we also get a warning which we shouldn't care about, so we can silence this by saying import os and then set os.environ, and then the variable is called tfcpp min log level equals, and then as a string a2. So now if we run this again, then this warning should go away. Yeah, so now we see it only printed the tensor. So this is a tensor with only one single scalar value. And we can also specify the shape by giving the shape argument. And this is a tuple. So in this case, we can say it's 1 by 1. And then we also can, for example, give it a data type. And here we can say tf.float32. So now if we run this again, then we should see the difference here. So now, yes, we also see we have the shape 1 by 1. So now it's not only a scalar value, but a matrix. And we have a different data type. This is with only a single value. Of course, we can also put in a list in here, so we can say, for example, 1 and 2 and 3, and now we have a 1D tensor. So here we see the shape is 3, and in this case we say this is a so-called rank 1 tensor. And of course we can also put in a list of lists. So let's create another list, and the first one is this one, and now let's create another list. And this has the values 4, 5, and 6. And now in this case, this is a rank 2 tensor. So now let's print this again and let's have a look at the shape. So here we see our tensor and we see the shape is 2 by 3. So this means we have 2 rows and 3 columns. So now in this case, we created the values manually, but there are also some methods to fill our tensor with some values. For example, we can say our tensor is tf.width ones, and then we can give it the shape as tuple, so let's say 3 by 3. And this is a 3 by 3 tensor filled only with ones. So here we have it, and we see that the default data type here is the float 32 if we don't specify any. So similar to ones, we can also use zeros. This will do the same thing, except that it fills our tensor with zeros. So here we see our 0 tensor. Then there's also a method that is called tf.I, and this only takes a single value. So in this case, let's put in a 3. So this will create the identity matrix, where the diagonal matrix or the diagonal is filled with ones and the rest is filled with zeros. So this is the I function. Then there are also methods to initialize our tensor with random values. So for this we can, for example, say tf.random and then draw some values from the normal distribution. So normal, and then here again we need the shape, so let's use 3 by 3. And here we can specify the mean, so by default this is 0. And the standard deviation by default is 1. So let's print our random tensor. So here we can see the random values, which are somewhere around 0. And we can also, instead of the normal distribution, we can draw values from the uniform distribution by saying tf.random.uniform. And then again, we need the shape. And here we can specify the min val. So let's say this equals 0 and the max val equals 1. So this means all of our values are between 0 and 1 and they are uniformly distributed. So here we have our new random tensor. So now we can also use the tf.range function. This is similar to the normal Python range function. So now we have values between 0 and 9. Oh, of course, I have to print it. So let's clear this and run this again. So yeah, this is our range tensor. And now let's see, by default, in this case, this is data type int32. So let's say we want to change this. So we want to cast our tensor. And we can do this by saying x equals tf.cast. And then again, the tensor we want to cast. And then the data type equals, let's use tf.float32. And let's print our new tensor. And again, notice that I assign it again to the new value because the original tensor is immutable. So let's run this. And then we see we get the same tensor, but now with a different data type. So this is how we can cast tensors. And now let's talk about operations on tensors. And what is important here is that all operations are element-wise. So let's create two tensors, x equals tf.constant and then a list 1, 2, 3. And let's use the same with a new tensor y, and it gets the values 4, 5, 6. So now, for example, we can do a element-wise addition by saying we have a new tensor c equals, and then we can use tf.add x and y. And now if we print our c, then let's clear this and run this. Oh, here I have a typo, constant of course. So again, let's clear this and run this. Then we see here's our new tensor 5, 7, and 9. And this is because we did 1 plus 4 equals 5, 2 plus 5 equals 7, and 3 plus 6 equals 9. So all the operations are executed element-wise. So this is important here. So instead of using this add function, we can also just use c equals x plus y. So this is doing the same thing. So now if we print this, then we should see the same result. Then instead of the addition, we can also use subtraction by calling tf.subtract or just saying x minus y. So again, this is doing the same thing. Then we can do element-wise division by saying tf.divide, or again, we can just use this operator here to divide our tensor. Then we can do element-wise multiplication by calling tf.multiply, or again, use the star operator. Then we can compute the dot product by calling tf.tensor dot and then x and y, and here we have to specify the axis equals 1 in this case. So let's clear this and run this, and now I have to remove this, of course. So let's run this again. So this is producing a single value. So what we are doing here is we compute the product of these values and then sum over all values. So 1 times 4 plus 2 times 5 plus 3 times 6. So this is a single value. Then we can do a element-wise exponential product with the double asterisk operator. So we can say c equals x star star 3, for example. So let's run this. So here we get 1 times 1 times 1 equals 1, 2 times 2 times 2 equals 8, and 3 to the power of 3 is 27. So this is the element-wise exponential product. Then let's do matrix multiplication. So for this, let's create 2 new tensors with the random function. So in this case, let's use random normal and the shape 2 by 2, and let's use the same for our y. And then to do element-wise matrix multiplication, we can say c equals tf.matmul and then x and y. And let's print this again. And then here we see we get the matrix multiplication result. And in this case, we must be careful. So here the shapes must match. So the number of the columns of our first tensor must match the number of the rows of our second vector. So this dimension, for example, if we use a 3 here, must also match this dimension. So here we can use a 3 by 4, for example. The only thing that is important is that these two numbers here match. So now let's run this again and see if this is working. So yeah, here we have a result, and the resulting shape is 2 by 4. So these two numbers stay basically. So this is matrix multiplication, and we can also overload this with the add symbol. So we can say x add y, and this is doing the same thing. Then let's talk about slicing and indexing. So this is the same with Numpy arrays or Python lists. So we can access them in different ways. So let's create a constant tensor with 2 dimensions. So a list of lists, let's say 1, 2, 3, and 4, and another list 5, 6, 7, 8. And now, for example, we want to access only the first row. So we get this by saying x and then the index 0. So let's clear this and run this. And then we see we only get 1, 2, 3, and 4. Then we can also use a colon here and then a comma. So this means in the first dimension we want everything. So we want all the rows but only column 0. So let's print this. And we see we get 1 and 5. And we can also do it the other way around. So we can say only column only row 0 and all the columns. So this is basically the same if we are only using a 0 here. Then we should get 1, 2, 3, and 4. So yeah, here we have the result. And again, here we can specify the start and stop index. So by default, it's going from all the way from the start to the end. But of course, we can also specify the start. So let's say 1 and let's say 3. So the last one is not included. So now this is only using index 1 and index 2. So we should get only 2 and 3. So yeah, this worked. So here we get only 2 and 3. And now if we put in 2 single values in here, then we access a specific element. So here, let's say we are in row 0 and we want column 1. So this should be the value 2. So let's print this. All right, so here we see value 2. So this worked. So this is how we can apply indexing and slicing. And now let's talk about reshaping of tensors. So again, let's create a random tensor with, let's say, tf.random.uniform, or let's use the normal distribution, and the shape should be 2 by 3. So let's print our x first. So let's clear this and run this. Then we see our shape is 2 by 3. So let's reshape our tensor. So we can say our new x should be tf.reshape, and then the original tensor is again our x, and then the new shape is 3 by 2 in this case. And let's print our x. And then this should work. Oh, I forgot the x here. So again, let's run this. And of course, we can only use shapes here that are matching, so that can be applied out of these original shapes. So in this case, it worked. We can also, for example, just use a single shape with 6 values. So 2 times 3 equals 6. This is why 6 is working as well here. So now we have a tensor with the shape 6, so only a 1D array. And you can also use a -1 here. For example, if we say a -1 and then a 2, then it will automatically determine the correct shape for you. So in this case, this should be a 3 by 2 again. So here we see the shape 3 by 2, so this worked. So yeah, and as I said in the beginning, a tensor is kind of like a Numpy array, so you can convert a tensor to a Numpy array and vice versa. So let's see how we can convert to a Numpy array, and this is very easy. So you just say our x, or let's say in this case, let's use x equals x and then call the Numpy function. So now if we print our x, then it should look the same. And if we print the type of x, then we should see that this is indeed a Numpy array. So let's run this. So yeah, we see our x has the same values as the tensor, but now we see it is a Numpy array. And to convert it back, we can say x equals tf.convert and then underscore to tensor. And then again, we put in the Numpy array. And now if we print the type of this one, print type of x again, then we should see this should again be a tensor. So yeah, this worked. And so we see this is a TensorFlow eager tensor, and you shouldn't worry about this now. So what eager tensor means is that it evaluates the operations immediately without building this computational graph that I mentioned in the beginning. So, but yeah, as I said, you shouldn't worry about this now. Just know that this is a tensor. And this is not only because I used this convert to tensor functions. So all of these constant value. So if I use tf.random normal, or if I use tf.constant and then a value here. So all of these are eager tensors. So here again, we see a eager tensor for this one as well. So yeah, these are all the functions that I wanted to show you. And now a couple more things that I want to mention. So instead of using numbers here, we can also, for example, use a string and get a string tensor. So let's print our new string tensor, and let's clear this and run this. So here we see we get a tensor with the data type string, and again here we can use a list and produce a 1D string tensor. So for example, we can use another name and another name, Max and Mary, and now if we run this, then we see we have a string tensor with a different shape with multiple values. So this is working as well. And then one more thing that I want to mention. So here, as I said, we used constant tensors, so they are immutable. But there is also a different kind of tensor, and this is a TensorFlow variable. So instead of using, for example, let's use 1, 2, and 3 with this constant function, we can do the same thing with tf dot with a capital V and then variable. And now if we print this, so now we see it looks the same, but we also get the hint that this is a TensorFlow variable. And a variable should be used when you want to modify its value. So for example, a TensorFlow variable is used to store the model parameters that we are then updating during training. But you don't need to worry about this now, because we are going to use a higher level API, and this is the Keras API. And this is doing all of this stuff for us, so we don't need to worry about using a variable and then updating the weights. So, but you should know that this exists, and this is different than a TensorFlow constant. And yeah, I think that's all I wanted to show you about the tensors, and I hope that you enjoyed this tutorial. If you enjoyed it, then please hit the like button and consider subscribing to the channel, and I hope to see you in the next video. Bye.